Hey everyone, I'm YUVARAJ, and this is the beginning of our journey into GNU Radio. Picturize this: you are at home, just you and your laptop, nothing fancy. And suddenly, boom, your computer becomes a radio lab. You start catching FM broadcast, reading signals from airplanes, even tuning into satellites flying across space. Sounds unreal, right? But nope. This is real and it's way simpler than you think. No complicated coding, no math nightmares, just neat little blocks. Connect them, run, and enjoy the magic. Welcome to GNU Radio, where signals come alive. So, what exactly is GNU Radio? Think simple. It's a tool that lets you build radios with building blocks instead of writing long codes. No syntax, no DSP formulas. You just drag a block for signal input, one for filtering, one for visualizing, connect them, hit run, and boom, signals come to life. Your PC alone is enough to stimulate radio systems like you are flying without leaving the ground. And here's the fun twist. You don't even need a hardware to start. Now let's look inside the GNU Radio. This is the main workspace called GNU Radio Companion. On right, you see all your blocks. Source, filters, sinks, tools, everything. The center is where you built your flow graph, connecting those blocks like a circuit. And at the bottom, you see messages, logs. It will be helpful when something breaks or doesn't run as planned. It's neat, it's visual, and you will be comfortable with it quickly. Let's start by creating a very simple signal path inside GNU Radio. The idea is just to generate a signal and visualize it. First, drag a signal source, followed by a throttle block. This throttle block keeps the processing stable and prevents CPU overload. Finally, add a Q2 frequency sync. This allows us to observe the signal in real time. Connect these blocks and hit run. On the display, you should now see a clear tone, steady and undisturbed signal. Now, let's change the story of this signal because real world signals are rarely this clean. So let's add noise through noise source. Use an add block to mix the noise with our tone. Send that mixture through the throttle and finally back to the frequency sync again. Run it and watch what happens. Exactly, the tone blurs, spreads and loses its clean shape. This is what noise does. Now we are going to recover the signal. For that, we are going to insert a low pass filter right before the frequency sync. Choose a cutoff frequency and transition width. Connect it, then run the flow again. The results speak for itself. The noise pulls back and the original signal rises to the surface. With just one filter block, we shaped the signal and restored clarity. And yes, that means you are already built your first low pass filter. So far, we created a clean signal, we added noise, we built a filter to fix it. Now let me show you something a little more advanced that I've already built inside GNU Radio. This is my AM transmitter and receiver setup. I'm not going to teach the block by block built here. We will have a dedicated video, but I will show how it works. On the left, I have an audio source. That audio is being transmitted using AM modulation. And on the right side, the receiver picks it back and demodulates it. Okay, I run the flow graph. And there it is. Audio is going in and coming out fully through AM modulation. Here No external hardware is used like SDR. Thus, entire communication is happening inside the GNU radio through 0 MQ ports. Okay, here is the end of the session. We began with simple tone, clean and pure. We introduced chaos through noise and then we shaped that chaos back into clarity. To end, we stepped into the world of AM transmitter, receiver, a complete communication loop inside software. Today was foundation building, and from here things will get more interesting. Thanks for watching. See you in the next one.